Hey folks, how's it going? It's Mr. Murray here, and I'm coming to you with a quick video all about describing transformations. So we've talked a lot in class about how to describe the transformations that will put one shape on top of the other. And I'm just going to sum up some of the big things that we've talked about. So if you need to go back and watch them at your own pace with a nice example, you'll have it there. So in this shape, what we know is we know that A, B, C, D is congruent, and we have to be careful with how we label it here. So I'm going to define it like this: to E, F, G, H. So first, notice how A has to go with E. B will have to go with F. C will have to go with G, and D will have to go with H. And what I'm actually going to do is I'm actually going to make this even easier for myself. And here's what I'm going to do. How about I make B go with H? So I'm going to go like this. I'm going to have B go with H. And then I'm going to have E, H, G, F. What you need to know about the lettering is remember that it does not matter how you letter them, so long as the corresponding points are in the same place. So this point A and this point E are in relatively the same place in their respective shapes. So I want A to go on top of E when I'm done, B to go on top of H when I'm done, C to go on top of G when I'm done, and F to go on top of, or D to go on top of F when I'm done. And as long as that happens, we're all good. Okay. So we need to describe the transformations accurately and precisely. So the first transformation I'm going to do is translate along the directed line segment, you could say, or vector, A, E. Now, and I'm going to put a line over it, in that it is a line segment. If you use a vector, you should put an arrow. But in any case, I'm going to translate it. And the purpose is that notice the use of A and E. The reason you do this, and I'm just going to move this around just for convenience, is that it's going to have the effect of taking A and it will guarantee that it's placed on top of E. And because these are rigid motions, that means that every other point is going to have to move in order to make that happen. Okay. Okay. So now what I'm going to do is I'm going to do another transformation. This happens to be a harder one. I want to talk mostly about the rotation. So here, the issue is that there are no marks on the graph to know exactly how much to rotate by. And a common question folks have been asking me is, Mr. Moret, how do I know how much to move? Because there's no exact measurement. And so here's what we've learned to do when you don't have the measurement, and this will be acceptable. First of all, I want to note that I'm rotating. And it's also important to note that technically these, that is A, D, B, I got my zoom interface here, sorry, B and C, which is up there, those all have prime marks on them because we've made a move. So basically, when I rotate, I need to get A prime, B prime, C prime, D prime to move. And I need it to go towards E, F, G, H. So that's going to require a clockwise rotation. And remember, clockwise Okay, that's the way the clock goes. Counterclockwise. That's against the way the clock goes. So I'm going to rotate clockwise about point. So I need the center of rotation. If you say A prime, you would be correct. But because E and A prime happen to be in the same place, if you said E, you'd also be correct. Okay, so it doesn't matter which one you say because I can see where it's at. I like to avoid the primes because they can get confusing. So I like to avoid using them if I don't have to, but it's a personal decision. Okay. So I have a rotation. I know the direction. I know the center. I now need to know the amount. And so this is what I said to do in class. Okay. Here's what we're going to do. So we're going to use the 3-letter notation. Okay. So we have the first letter, the second letter, the third letter. Okay. And as a reminder, basically, if I have an angle here and it's centered at B, okay, the center or vertex is at B, and I know like 2 points along the rays or segments that such that the space between them creates that angle, then you call this angle ABC, or you could say CBA. CBA, doesn't matter. Okay. So here's how I told folks to do it in class. Choose a starting point and choose the image. I call it the ending point. So you call this the pre-image and the image, but I call it the starting and the ending. So for example, I want B prime needs to end up on top of H because you notice how B goes with H. So I'm going to put B here. I'm going to put H here. And what's the center of rotation? You told me already, it's point E. Okay, so rotate clockwise about point E according to, or you could say by angle BEH. Okay, now when I do that, and by the way, this is the angle. Let's accentuate the angle here, BEH. So as you can see, when I go about this angle, this is the angle I'm referring to right here. So to rotate about an angle, I'm going to simulate the point here. So to rotate about an angle means I'm going to move according to this angle, but the H needs to be the same distance from the center of rotation as B. And that's the case because we know the measures of all the sides are equal because we already know the shapes are congruent. So B is going to have to move according to this angle to H. But every other shape, point that is on the shape, is going to have to move by a similar amount, right? So just because as B moves to this point, every other point also is moving because this is what we call, remember, a rigid motion. Okay, and so when we're done, I'm just going to clear this stuff out of the way. When we're done with the rotation, maybe I can rotate the right shape. When we're done with the rotation, one will more or less lay on top of the other. It's not perfect on the picture, but one is going to lay on top of the other, and that establishes that the shapes are congruent. Okay. So there's many different ways to do a congruency proof. You only have to know one way. The big takeaway, again, that we learned in class, especially when you work with rotations, is this idea of choosing a starting point and then setting the last letter to where that you want that point to end up, and then setting the middle letter to be the center of rotation. All right, folks, so hopefully this example helps, again, give you another like sense of how we go about running some of these transformations. You can see here I added another bullet point if I needed to. Some of us will be able to do it in 3. Some of us will be able to do it in 2. As long as you get one shape onto the other completely correctly, it's fine. All right. You do it in as many steps as you need. All right. Thanks again for watching. Have a wonderful day. And don't forget to love math.